So we just start the next lesson in circles. So we'll work out some problems based on the theorems that we know. So in figure A, B, C are 3 points in a circle. So in the all circle, first we will draw the diagrams to understand the nature of the problem. We can solve it quickly once we draw the diagram correctly. A, B, C are 3 points in a circle with center O such that angle BOC is equal to 30 degree. So we are not when mentioning, please make it a point to know it. Angle BOC, we have mentioned it as 30 degrees. So the ABC is a segment. 3 points on a circle with center O. Angle AOB is equal to 30 degrees. So the total AOC is 90 degrees. If D is a point on the circle other than the arc ABC, that means the remaining part of the ADC. Find angle ADC. So any point on the circle. So it's very simple problem, direct application. Now D is any point on the circle other than arc ABC. Circle in rather you can mention it as ADC, this side, other than this ABC, except or ABC. So what the theorem says, AOC, angle AOC is 2 times angle ADC. AOC we know it's 90 degrees equal to 2 times angle ADC. So ADC angle is equal to 90 degree divided by 2. Divide 2 by 2 both sides, you get it's 45 degree. So by the way, this D point can be here also, same room of anywhere. The angle subtended by AC at any point is same. Is half of angle AOC. So the point D can be here or here at any point it's 45 degrees. So we'll try next problem. A chord of a circle is equal to the radius of the circle. Is this given? Chord is equal to radius. So we'll draw a circle in all this problem. First we will draw a circle so that we'll draw the diagram to understand what is it exactly. A chord of a circle is equal to the radius of the circle. Let us take an example. O is the center. Let us take this is a chord AB. We'll mark. What he says, OA is radius equal to OB. It's also equal to AB. AB chord also is given. So, and AOB is an equilateral triangle. Therefore, AOB triangle AOB is equilateral triangle. So what he says, find the angles subtended by the chord at a point on the minor arc and also at a point on the major arc. So first let us try with major arc. So let us take this point as here. What is the angle? Half of AOB. What is this AOB? Equilateral triangle means it is 60 degree. What about this? ACB is 30 degrees. How? As by the theorem, angle AOB is equal to 2 times angle ACB. So AOB is 60 degree equal to 2 times ACB. So angle ACB is equal to 60 degree divided by 2 is equal to 30 degrees. Any C can be any point. What about what it says? Angle subtended by the car at a point on the mind. This is on the so this angle subtended at this is major arc. So this ACB is major arc. What about minor arc? So we'll take some point C dash. So we'll make some construction. We'll join A, C and C, B, C dash or A, C dash. Now, what is this angle ACB? That's what he says. By the chord at a minor arc and also at a point in the major arc. So AC dash C is the minor arc. So angle subtended by, if we take this one, angle subtended by minor arc ACC dash B. So we'll see, consider that quadrilateral ACBC dash. C plus C dash is equal to 180 degree. We know what is C. We have worked out C. So C dash equal to C dash plus 30 degrees. C equal to 180 degrees. Therefore, C dash is equal to 150 degrees. 180 minus 30. So in this case, you can see the angle subtended at major arc is less because it's bigger. Angle subtended at the small arc is angle is more. So next problem. In circle, we just go through there. What are the important points? Then we do. We can work out. So next problem. In the figure, angle PQR is given as 100. This problem we have to study the diagram first, then to understand. Now see the marked. A circle is there. PQR are points on a circle with center O. What he says, find the angle OPR. So diagram is given. Now we know angle PQ. PQR is given. PQ angle PQR is equal to 100 degrees. So we have to find the angle of OQR. So we'll just draw, we'll take any point in this line. So say if we take Q dash, what is this angle? PQ dash R. Now we know PQR is 100. PQ dash R is no the quarter. This is in this quarter in quadrilateral. You take any point, take any point. Okay. major arc PR as Q dash. So what about now angle Q plus Q dash equal to 180 degrees. Now theory of this quadrilateral theorem. Quadrilateral cyclic. Therefore, we do Q dash equal to 180 minus Q. Q is 100 degrees equal to 80 degrees. Now we have found one. Now we know this we have found now. This is 80. So we will apply the next theorem. Now this is first theorem. Now we have applied and found. We have found one. Next theorem. What is that? We want to find the angle of OPR. So we know OP and O are equal. OP and O mark equal to radius. So if we know, we will apply the next theorem. If the angle PQ dash R is 80, angle PO R is 160. So angle subtended by arc PR at the center is double out of angle subtended any other point. So we'll apply theorem. Angle POR is equal to 2 times angle PQ dash R equal to 2 multiplied by 80 degree equal to 160 degree. So this also we have now found. This is 2. So in triangle POR, we do one angle. So angle OPR plus angle ORP plus angle POR is equal to 180. So we know POR, these two angles are equal. OPR is equal to ORP. So these two is an isosceles triangle. In triangle POR, OP is equal to OR is equal to radius. So it is isosceles triangle. That is, those two angles are OP R is equal to ORP. So now these two angles OPR plus ORP plus 160 degree is equal to 180 degree. Now we'll these two, if we combine, is 2 times OPR is equal to 180 degree minus 160 degree equal to 20 degrees. Or angle OPR is equal to 10 degrees. This will write clearly again. Is 10 degrees. So in this problem we have 2, 3. One is we have used as a what is the property of cyclic quadrilateral, and the angle subtended by a chord PR at the center and any other point that we have used, and we have used the isosceles triangle to find out the other angle. So we'll move to next problem. In figure, angle ABC is equal to 69. So we have marker. So BC is a chord. So angle subtended, so angle ACB, what is that? Angle ACB is equal to 39. Now two angles they have given. So in triangle ABC, angle B is equal to 69, angle C is equal to 31. So we can find out what is angle A. Angle A is equal to 180 minus these two. So angle A is 80 degree. We combine all the three. Angle A is equal to 180 degree minus 69 degree minus 31 degree. So it's equal to T. So we have found out this one now. C is 80 degree. Then angle subtended by the chord BC at any point on the circle is same. So if this is 80, this angle also is 80. Find angle BDC. The angle BDC. Therefore, angle subtended by chord BC at A and D are equal by theorem. Therefore, angle A is equal to angle D is equal to 80 degrees. This is the answer. So generally in the circle they give the diagram, or we have to draw the diagram to understand which concept, whether it is cyclic, use the center point to find out the angle. If we know the one angle, we can find out the other angle easily by applying one or the other formulas. So next problem we'll try. In figure ABCD, 4 points on a circle. AC and BD, as shown in the diagram, intersect at point E, such that angle BEC is equal to 130 and angle ECD equal to 20 degrees. Degree we are not able to type, you can add wherever possible. Find angle BAC. Now angle BEC is given. What is that angle? BEC is equal to 130 degrees. Sorry, here. Next, angle ECD given is angle ECD is equal to 20 degrees. These two are given. Now we know angle BAC is equal to angle BDC. Angle subtended by the same chord BC. Now, so what about angle DEC? Angle DEC is equal to, simply it's 180 minus 130 is equal to 50 degrees. So this is 130 given, the straight line, the balance, this line is 50. This is 50. We know this angle, given. DC, ECD is given. ECD is this. What about this angle? This is 20 degree. So 50, yes, 20. These two angles put together, 70 degrees. The balance is the remaining angle. We don't know BDC. Therefore, BDC, angle BDC equal to 180 degree minus DEC minus DCE is equal to 180 degree minus DEC is 50 degrees. DC is given. DC or ECD, both ECD is 20 degrees equal to 110 degrees. If BDC is so by 2, so we know by 1 and 2, BDC, angle BDC equal to angle BAC. So angle by 1 and 2, angle BAC is equal to 110 degrees. So in the triangle, we have to observe what they have given, what we can find out. We can find the third angle. What is it? So we have worked out some examples. What we have observed, we are trying to remember the theorem. We're trying to apply. If we know one angle, we can find out the either complementary angle or supplementary angle or double the angle in center, or we use same chords, subtend same angle, or some. We apply these 3 points. We are the cyclic quadrilateral. We apply one of these points, we get the answer. So angle subtended by the chord is same at same side of the segment. So one of these theorem will get us the required. If we are not able to get, please read the theorems again. So we have come to end of this class, and thank you very much for listening. Please try to repeat the problem and see whether you have understood the concept. If any doubt is there, please write to us. Thank you very much.